All right. Hello, everyone. Welcome to my talk on machine data in Industry 4.0, how to handle it better. I'm really happy to see all of you here. But before we get started, I'd really like to get a feel of the demographics of this room. So, how many of you are data engineers or work as a data scientist? Okay. How many of you have worked with any kind of databases? Nice. How many of you have worked with IoT in any capacity? Cool. And how many of you do not like to raise your hands? Nearly got you there. All right. So today we will talk about a couple of topics which include the Industrial Revolution and Industry 4.0 itself, sensors in factories and why it makes sense to use them there, and the kind of workflows that they enable in an industrial context. We shall take a look at why digitalization projects fail and what we can do to skip this trend of failing IoT projects. After that, we will take a look at the CreateDB ecosystem and learn about what characteristics of CreateDB sets it apart from the other databases in this segment. And finally, we will go through a case study of a smart factory which has made six-figure savings in 2018 by making a switch to CreateDB. We'll also take a look at what kind of data is coming in from the actual smart factory and so on. My name is Tanay Pant, and I currently work as a developer advocate at Createio in Berlin. I really enjoy working with time series and sensor data. I'm a tech speaker for Mozilla and I volunteer to their various projects in my spare time. So I've published books on Firefox OS, building virtual assistant on Raspberry Pi, and web-based virtual reality. I also run a podcast called Technically True, where we talk about public speaking, developer relations, and data. So if you have some time, do tune in. All right, so let's get started. So dating back to around 1760, the first industrial revolution was the transition to new manufacturing processes using water and steam. So it witnessed mechanization, a process that replaced agriculture with industry as the foundations of the economic stability of the society. And it was hugely beneficial in terms of manufacturing a larger number of goods and creating a better standard for living in terms of some people. And this made machine use more feasible. And the idea of manufacturing with machines quickly spread, and machines allowed faster and easier production of material, and they enabled all kinds of technical innovations. Then by the beginning of the 20th century, electricity became the primary source of power. And it was way easier to use than water or steam, and enabled businesses to concentrate power sources to individual machines. And it was commonly referred to as the technological revolution. Mass production of goods using assembly lines became really commonplace. And lastly, just-in-time manufacturing and lean manufacturing principles further refined the way in which manufacturing companies could further improve their quality as well as output. Then around 1970, the third industrial revolution involved the use of electronics and IT to further increase automation in production. So manufacturing and automation advanced considerably thanks to internet access, connectivity, and renewable energy. So the invention and manufacturing of electronic devices such as transistors and IC chips also made it possible to fully automate individual machines to either supplement or even replace operators in some cases. So this period also spawned the development of software systems such as ERP tools that enabled us to plan, schedule, and track product flows throughout the factory. And finally, the fourth industrial revolution is the era of smart storage systems, smart machines, and production facilities that can autonomously exchange information, trigger actions, and control each other without any interventions from humans. So it connects the Internet of Things with manufacturing techniques to enable these systems to share information, analyze it, and use it to guide intelligent actions, and also incorporate technologies like AI and artificial and robotics. So the development of new technology has been a primary driver to the movement to Industry 4.0. And the applications for the industrial sector are already quite huge, such as predictive analytics and real-time decision making. Now that we know what the four industrial revolutions were and what Industry 4.0 is, let's take a moment to talk about sensors in factories. So factories all around the world have been working with a number of different solutions, and they are working to transform the way how their manufacturing processes work. So these systems aim to control and provide real-time feedback by recording data from different sensors, motors, and valves. And all this data that is gathered contain multiple values and parameters depending upon the sensor from which that data is coming, along with a timestamp. And this timestamp makes this data time series data. And this complex time series data that is coming in at high speeds also needs to be queried in real time. And the data is sent via protocols like MQTT, via maybe a pipeline like Kafka, to time series databases like CreateDB, and finally visualized with dashboards from Grafana, Power BI, or even Apache supersets. So over the past few years, we have heard a lot about this digitalization buzzwords. So let's now take a look at what has actually been going on with these digitalization transformation efforts. Well, according to surveys and reports by these institutions and companies, a huge majority of these digitalization and IoT projects fail. What's worse is that about 30% of these projects fail at the proof of concept stage. Again, these companies, McKinsey, IDC, and Microsoft, conducted some research and studies around this topic, and they found that there are 3 primary root causes of why this is happening. So first of all, we do have a lack of necessary scale in the specific industries. Secondly, we have siloed and resistant corporate culture. Well, resistance to change can of course be a big deterrent to progress. And finally, we have data and IT infrastructure, which is quite interesting considering that this is the only technical issue in a list of more people-related challenges. But if you think about it, we have come a long way dealing with data, and we have amazing tools and databases out there, and they have been working quite successfully till now. So then what happened all of a sudden? If you look at the last decade, you can say that it's a machine data world. And machine data means explosive growth. So in 2018, we saw a boom in the number of IoT devices and their use cases. So there was an increase in the use of IoT in different contexts like smart factories and smart cities. And the total number of IoT devices is moving towards 20 billion by the year 2020. And every second, another 127 devices are being connected to the internet. Just as an example, take a Boeing 787, which generates about half a terabyte of data just during a single flight. And if we talk about the plastic manufacturing industry, and I know it's a bit specific, but there's a wide array of data being produced per bottle. And there's data per production line with about as much as 10 production lines per factory. And this data is being generated by around 1,000 different types of sensors, and that's just one factory. This particular company that we are going to talk about has about 180 different factories spread across 45 countries. This means data on billions of bottles. So there's a good chance that the bottles that you're using in your refrigerator have been running its data through the Create platform during its production cycle. But we'll talk more about this company and the data generated by it in a while in our case study. So just like we had our 4 ages of industrialization, we also had 3 generations of databases. So first of all, we had legacy databases, which were used in an environment with mainframes with a client-server setting, and were quite often used with ERP systems. So it dealt with low to medium volumes of data, which was ingested at really low velocity, and the data itself didn't have much variety. So what was expected of these systems was consistency, reliability, and standardization. These databases were made by companies like Oracle, IBM, Terabase, and Sysbase, just to name a few. Then we have the next generation, modern databases, which are used for cloud services, mobiles, and handling big data. Essentially, web-scale use cases. So it deals with high volumes of data coming in at high speeds, but the data variety itself is somewhere between low to medium. And some of the characteristics that are required in these cases, in these use cases for these kinds of databases, is that availability and redundancy, enablement for faster application development, so higher agility, and supporting massive numbers of concurrent users. So vendors like Hadoop, MongoDB, Splunk, Microsoft, and Amazon came together to help us out with databases for these specific use cases. Now, applications and users have been forced for database innovation in the past, but the machine data world has outpaced the database industry. So there are use cases like connected things, edge computing, convergence of OT and IT, interoperability, and even instances where machines become users. Here the incoming data volumes are really high, the velocity is very high, and the variety of data, just because they are coming from different types of sensors which have different manufacturers, is also really high. And there are specific characteristics that are required from this generation of databases. And that's fast data ingestion along with real-time analysis, easy scaling to many locations and machines, and finally flexibility to operate at the cloud as well as on the edge. So there's a serious deficiency of databases in this sector. So at Createio, have anybody of you used Createio in some capacity or heard of it before? None of you. Okay, so let me introduce you to Createio. So we have been working on developing technical architecture in IoT and time series field over the past 5 years with companies like McAfee, Nokia, Rauch, Alpla, and many more. To learn about the CreateDB ecosystem, let's start off by going into the heart of the honeycomb, to the CreateDB core itself, and talk about what makes it stand apart from various other databases in this perceived segment. So CreateDB is a distributed SQL database that is best suited for handling industrial time series use cases due to its ease of use and ability to work with many different terabytes of data structures. So CreateDB is quite simple to install. You can spawn it off by a single line of code on your Docker or on your terminal. And CreateDB uniquely combines standard SQL with NoSQL benefits. So it operates on a shared nothing architecture, which gives it an edge over systems like PostgreSQL, which are running on a master-slave architecture. So various nodes in a cluster coordinate seamlessly with each other, and the execution of write and query operations are also distributed automatically throughout the different machines that are running in a cluster. So there are some other things about CreateDB, like it is NSI SQL compatible, which includes joins and Postgres via protocol, which makes integration with tools like Grafana really easy, and it also prevents lock-in. So it also supports SQL, distributed SQL with full text search, JSON, time series data, geospatial data, and even blob tables. This architecture is quite well suited to containerization, so that your data layer is also designed in the form of microservices, meaning that a cluster that is running on Kubernetes can be scaled up or down in minutes, in seconds, instead of which took weeks, because you can just now use the kubectl scale command for that. And operations like sharding, replication, and rebalancing of data as the cluster size changes are automated. So until recently, workloads like this often required a NoSQL solution like Cassandra, Elasticsearch, or InfluxDB, often in combination with a traditional relational database. So CreateDB makes it possible to handle them in a single system without sacrificing the power and familiarity of SQL. And this fire hose of complex data that is being generated by factories needs to be handled in real time in order to take real-time actions on the factory floor. So let's now talk about the next layer of CreateDB technology, that's CreateDB Cloud or CreateDB on Azure. So CreateDB Cloud is a scalable SQL service that is hosted on Azure, and it's quite ideal for industrial time series use cases. So it has real-time query performance for partitioning, parallel processing, and in-memory columnar indexes, which enable real-time and complex AI, not just time series aggregates. And it also has Azure IoT integration with built-in interfaces to Azure IoT Hub, MQTT, Postgres via protocol, JDBC, REST, and a native .NET Core driver. So let's now get back to our smart factory use case. So smart factories essentially have a huge number of sensors that are used for monitoring a large variety of things like temperature, pressure, humidity in a factory. And every day millions and billions of data points are being generated by these sensors in smart factories, smart cities, and in the health industry. So this data needs to be ingested in real time. And since the different sensors are produced by different manufacturing companies, this data tends to be complex and can be in many different forms. So this data, although it has valuable insights about the operation, but it can only be obtained from it by querying and running analytics on it in real time. So queries like aggregation and time series analysis, along with machine learning or predictive analytical models, are often applied on this data. And the insights that are produced by these analytical operations can be used to improve the efficiency and functioning of these various industries, hence causing significant cost reductions. So the differentiating factor that should be kept in mind as compared to other time series use cases is that real-time queries are under highly concurrent load, that is from stream processing or machine learning, and must access gigabytes to hundreds of terabytes of data. So now I would like to share with you a story of one of our customers named Alpla. Have any of you heard of them before? None of you. Okay. So most of the people in the world use their products at least once a week, be it CocaCola, Head and Shoulders, or Dove. So Alpla is well known in the consumer packaged goods market for its innovative plastic packaging systems, bottles, closures, and injection molded parts. So in 2017 alone, Alpla produced over 100 billion consumer good products. And with over 100,000 tons of recycled plastic, it is also one of the leading packaging company when it comes to minimizing plastic waste and maximizing plastic reuse. It's also known as the closed loop plastic economy. And we have been working with them from the past 3 years. So this is where real-time information from the shop floor has the potential to add value to 180 factories across 45 countries. So they have sensors for temperature, pressure, blending ratio, and other settings that need to be really precise on every single machine. And when these settings are right, high-quality products are the result. And when these settings are off, quality suffers, and the production costs increase. So imagine a factory floor like this with just 4 production lines. And let's say each of these production lines have 4 pieces of machinery each. So does anybody have any ideas how they actually discovered issues in the machines in the factory? Anyone? Okay. So in the factory, they usually have some kind of visual indicator like a LED bulb, which shows if everything is working correctly or not. So in order to discover these issues, multiple people had to be continuously moving along the factory, checking up on every machine. And one of the typical scenarios that can happen is that an employee is currently working to fix the issue on production line 1. So once they finish that, they go through all the other lines to check up on the machines. And that is when they realize that there is something wrong with the production line 3, machine 4. And upon taking a look at what's up, the people realize that some parameter needs to be adjusted on line 3, machine 1. And then the person has again moved to a different location to fix that issue. So in factories, production lines are laid over the whole factory, and distances between these different machines can be considerable, which meant that this was a really slow and labor-intensive process. So additionally, the latency that was introduced by having to walk through the whole factory meant that many products were often affected by a defect even before they were spotted by an operator. So this resulted in the loss of valuable machine time and a loss of raw material, because that meant that defective material was being produced until the problems were fixed. So Alpla's market entry in North America in 2001 was followed by years of tremendous growth. And in 2015, it was already operating 14 manufacturing plants with more than 1,000 employees in the USA. And with this growth came the challenge of hiring and training enough personnel to run the complex manufacturing processes. And because modern manufacturing machines often require a different sort of complex user interface, every plant required specially trained experts for every single machine on every single shift. And as a result of this rapid growth of data, database performance degraded. And response time for queries got longer and longer, which meant that real-time actionable guidance was no longer possible. So Createio built their proof of concept on the top of CreateDB Cloud and enabled them to drive technological transformations. So the first step was to send data to CreateDB alongside the existing SQL database. So performance of the system improved immediately, and reports and analytics could be generated again in milliseconds instead of minutes. And the system became capable of giving real-time actionable guidance. So this allows Alpla to establish a closed loop of continuous production state monitoring and process improvement based on the data that is being sent by the machines. So let's take a look at how this whole system looks like. And let's hope the demo and internet gods are kind today. Is it visible in the back? So this is what the admin UI of CreateDB looks like, and this is the Alpla cluster that is running on production. So as you can see here, we have 5 nodes, just a 5-node cluster, and we have about 2.2 billion records of data. So let's take a look at what the data looks like when it's coming from the factory. So to understand how this works, also let's follow the journey of the data. So first of all, we have a raw table. So it has about 60 configured shards and 56.7 million of data. So if you can see the schema, then it doesn't have a lot of different points. It just has some payload information, partitioning information, and a timestamp. So let's take a look at what this data looks like. So this is the main section. This is the payload of the data that is coming from the sensors. If you take a look at the metadata, all of these readings have a plant key, which denotes like which factory this data is actually coming from. So this denotes that this data point came from the Iowa factory in US. And if you take a look at the data that is coming from these sensors, you can see that it has an array of 101 items. Now let's take a look at some other records. So here you see we have an array of 129 data points coming in. So all these sensors are sending different kinds of data to Createio. And it's possible to hold all of them in a single column because Createio supports dynamic data typing. So what happens is once we get this data here, we start off an enrichment process. So what this enrichment process does is basically it takes all this nested information from the JSON payload and it splits it into different columns. And then those columns are strongly typed to increase performance. And then we have a metric table. So once the data is enriched, we end up with this metric table. So we have this metric table with about 2 billion records of data. And if you take a look here, we have now much more columns. And of course, since not all the data points look alike because of the difference in manufacturing sensors, we have a null value here. And if you have worked with MySQL before, you might be thinking that this is an incredibly inefficient way of handling this because that takes space. But with Createio, it doesn't actually either take up space or affect query performance. So let's take a look at some queries that are running with the Alpla mission control. So I have 3 queries here, and I'm gonna copy and paste that. So we have a query here from which I want to know all the alarms that were generated by the different factories by the machine model BUMU 200, maybe because I wanna change this machinery. And as you can see, we are iterating over 2 billion records, and we got the results in 1.3 seconds. Let's take a look at one more query. So what we have here, we just talked about production lines in a factory. So we want the data or the location of the production line. We want to know the downtime reason why this particular line was down. And then we want to know when it started, when it finished, and how long it lasted, and like how old it is as well. And then we have some certain conditions here, like let's say I'm going to the McDonald's plant, so it stands for MCD. I want data from just that particular factory, and I want the downtime reason to be cleaning of tool, maybe because I'm trying to reduce downtime by making it more efficient how we do the cleaning of tools. So if we run this query, we have again a sub-second query, and we get all the information about the downtime reason, when it started, and so on. Now, if you take a look at the cluster section of the admin UI, you'll notice that we have 5 commodity servers, 5 commodity nodes with just 15 gigabytes of RAM, and still it's able to maintain a great amount of performance as compared to some other databases. All right, let's get back to this. So when the Createio T-Data platform predicts an unusual change in data, it alerts a factory expert operator in mission control. And this is an actual picture from the mission control for Alpla, which is based in Atlanta. And it looks like this with different dashboards for different factories. And you can see you have the names of the different factories on the top of the different columns. Now the operator just alerts somebody at the factory via a mobile notification system, suggesting an adjustment or a repair. Now, since the employee on the production floor has real-time actionable guidance, they are able to, once they are fixing the first issue, they get a notification saying that something is up on production line 3, machine 4, and to fix that, they need to go to the first machine. And this way, once their current issue is fixed, they can move directly to the place which is causing an issue. And after the issue is resolved, the factory operator logs a note explaining how this was fixed and how the issue was resolved. So the notes are shared via online manuals across all the factories to improve knowledge and sharing of best practices. And that is how we close the loop, by using this data to make real-time actions on the factory floor. So every plant in Alpla using CrateDB saw improvements in the net equipment efficiency, with some having efficiency greater than 90%. And every plant also saw a reduction in manual process adjustments as much as 50%. And reducing the number of manual adjustments stabilizes the process and significantly improves production efficiency. So the result was a six-figure saving in just 2018. And currently there are about 2.5 million queries per day. And work hasn't even finished yet. It's estimated to increase about 18 times by the end of 2020. With this, I'd like to conclude my today's session on machine data and Industry 4.0, how to handle it better. So we talked about the 4 industrial revolutions, sensor in factories, learned why digitalization projects fail, the CrateDB ecosystem, and finally did a case study on how Alpla made technological transformations with CrateDB along with a sweet 6-figure saving. If you have any questions or interesting ideas, feel free to reach out to me and I'd be really happy to collaborate. I look forward to seeing what you do with this. Thank you.